skills of the students, but also the team. So maybe you do this now, and so you can give us feedback in 2 minutes time without reading any article anymore. So, so you can spend your time for traveling around the world. Well, so now you know what my research is about, and in the beginning, I wanted to tell something about why we should teach statistics. And during my research, I soon came about Hans Rosling. Maybe you know him. He's the inventor of Gapminder. I will explain later on what Gapminder is. But he started in 2000. Giving some talks and asking the people questions like, do you know how many children of all countries worldwide are vaccinated against measles? And he gave them 3 options to answer: A, 20%, B, 50%, and C, 80%. So, and he asked this question to thousands of people. And normally you would think, okay, if you give, it's an example of him. If you write on a banana A, B, and C, on 3 bananas, and you throw them into a cage where there are some apes, they will grab a banana and eat it. And the banana with the letter the ape eats as in the first time is the choice. So you will have a probability of 1/3 that the ape is right. The students and the professors and the doctors and all the people Hans Rosling was asking, they estimated around 19% right, so 19, 20, 21% right. So they were not even as smart as the apes. This is his example. Normally he asked 13 of the questions, so maybe if you look up for the 13 Gapminder questions, he asked 13 of the questions, and normally you should get right 4.3 and so on questions right. But on average, people guessed right around 2 to 3 questions. So he was thinking that we are biased in how we perceive our world. And therefore, he started with his Gapminder project and to collect data from all over the world that he can spread factfulness. He's calling it factfulness. He wanted to spread facts about the world with his software. No. So the software looks more or less like this, or this. There are different tools that you can use. Downside, you see the bubble chart. Upside, you see some distributions of income, and the colors are the income groups. So from small income groups to high income groups. And as you can see, one thing he wanted to spread is that the term third world is an old-fashioned term, and it isn't existing anymore. Because when I have learned it in school, it was in 1987, so we heard, okay, there is a third world, and then they are not earning so much, and we are the rich world, and there is a gap between. And nowadays it looks like this, so there isn't a third world anymore. Or here you can see on the x-axis you can see income, and on the y-axis you can see the CO2 emissions per person in tons. And well, the thing we can conclude out of this graphics is there is no third world anymore, but the more money we have, the more we waste it for the pollution of our environment. And as you can see, these graphics are giving a lot of information more than I tell you now. because they're the big red bubble. This is China, or here we have India, or the green one. This is the USA. Why do I know this? Yes, okay. The size of the bubble is the size of the population. So you know the big ones are India, China, America, and so on. There is also the year, and there's a play button. You can see the data coming from 1830 or something like that. He has collected data over many hundreds of years. Okay, so one citation I wanted to include into my presentation is: graphical excellence is that which gives the viewer the greatest number of ideas in the shortest time with the least ink in the smallest space. And this is, I think, this is totally hitting the point. So, yeah, there's a theory behind it. The theory behind it is that we are able to intuitively understand statistical graphs. This is a theory of Fishbein, and he did it in 1987. So especially graphics are potential to get our intuitions, that we can get intuitions of the displayed data behind. Moreover, heuristics and biases, not Fishbein, but Tversky and Kahneman did a lot of research on heuristics and biases, and that we are biased when we judge on uncertainty. So we are not always right with our intuitions, but we have to overcome the biases and the misconceptions and towards a factful worldview. The importance of context, it's a newer thing. Especially Maka and Ben-Zvi also, they did a lot of research on the importance of context. And there's another thing, the cycle of inquiry and visual analysis. This is what I do in school. So here we have the cycle. We entrance with a question or a task. We look up for data. We try to visualize the data. Then we develop insight into the topics behind, and we are acting like, should we ask a new question, a further question, or should we ask the question again? And we use this one in school. We have used this one in school, and we are still using it. In grade 8, we have visited some school classes that did a project about the relevance of poverty, and now actually we are doing a statistics course with mathematics teacher education here at the JKU, and they also use the Gapminder data to get insight into some statistical problems and to further work on them. And this is what my project is. So first we introduce the Gapminder software, then we do some investigations with the Gapminder software and with some graphical representations. And third, we download the data sets from Gapminder. You can download the data sets, and we work further with them in GeoGebra or SPSS. Graphically, it's looking like this. There we have the Gapminder data. It's income by income groups. And then we work further with the data. Here we have the SPSS data, and we can do, for example, some ANOVA, or in GeoGebra, we can display some box plots and have the statistical numbers there, so we can calculate the minimum, the maximum, the quartiles, the median, and so on. So there we got the way from the visualizing to formalize the findings and to grasp them mathematically and to work further. So the outcomes. Do I have still 1 minute for the outcomes? 1 minute. Okay. Students understand statistical ideas intuitively. That's one of the most important things, that they can do statistics with graphics. They learn multidisciplinary. So, for example, we did something about education for sustainable development. You could imagine that with the data from Gapminder, you can do geography, you can do history, you can do a lot of things with that. And they can turn their intuitions into knowledge by formalizing their statistical reasoning. So this is the main outcome, that it's worth to work with the Gapminder data from intuitions to the mathematics part. Okay, thank you for questions and feedback.